So infiltration, right? Infiltration, the definition is shown to you. That is the amount of the process by the process by which a water percolates the earth surface with the moisture or the soil pores. That is the infiltration, right? So process by which water enters the ground and flows through the soil underneath, that is called the infiltration. Infiltrated water first meets the soil moisture deficiency and then moves down towards the to reach the ground water table. Now at the time where we had discussed about the hydrological cycle, in that particular section as well, I have told you that first of all, if the intensity of rainfall is not so high, then you can see the water is being soaked, right? Where the water is going, where the rainfall is going, it is going beneath the earth surface. Basically it is soaked or infiltrated to the earth surface. Now what will be the amount of water with what will be with that amount of water, where it is going? Actually it is going to meet the groundwater table, as because we know the groundwater table is there beneath our ground surface at a certain depth, right? It is not actually that you dig 1 meter or maybe 1 foot you will get the water table. It is not like that, but obviously you are having some sort of water table beneath the ground surface. Now eventually it will meet the ground surface or the groundwater table, but first of all the water will be soaked by the soil itself. It will fulfill the deficiency of the water in the soil mass. So basically it will hold the water first of all with its capacity. I have told you field capacity it is. So with respect to the field capacity, it will hold the water, and if the water amount is larger than that, it will be infiltrated and it will eventually meet the groundwater table. Clear? So the infiltrated water first meets the soil moisture deficiency and then moves downwards to reach the or to meet the groundwater table. Now this will be the basically diagram by which you can find out how this is happening. So first of all, saturation zone will be there. If the saturation, so suppose the rainfall is occurring at a certain intensity, so first what will happen? Moisture content of the water will be increased. It will reach to the saturation level, and with respect to the depth, initially we will have some sort of saturation level, then we will have some sort of transition zone, then we will have transmission zone, and ultimately we will have waiting zone, right? ওয়েটিং জোন যেখানে গিয়ে তোমার ওয়েটিং না ওইটা উইল্টিং ছিল না না গ্রাউন্ড ওয়াটার টেবিলে গিয়ে পৌঁছাবে তোমার ডেপথের সাথে গিয়ে and you can see here with respect to the moisture content depth is given. Clear? So if the rainfall is occurring, the moisture content at the top will be higher, reaching the maximum one, that is the saturated. The maximum value of the water content is the saturated one. So it is being saturated, then other zones are there. Eventually obviously the water content will be zero maybe. Now how this infiltration is occurring, this is one sort of example you can say. Suppose you are having one pot is there, suppose, right? A vessel is there, and above the vessel one lead is there which is having some pores, right? Some pores are there in the lead of the vessel, and suppose you are pouring water, in the lead. ফুটো ফুটো থালা দেখেছো তো? Take a saucepan, make that sort of thala as a lead and pour water. If you pour water in a low intensity, means a small amount of water in a larger time, all the water will be collected or flow through those pores, and it will be collected in the thala to upore roilo baba, the saucepan, right, the vessel. ঠিক কি না? Now suppose you are pouring water in a higher rate. Certainly you are pouring water, one bucket of water. What will happen? Obviously all the water will not be going inside the vessel, rather than it will flow through the surface of that lead, right? This is happening over there. It depends what is the intensity of that input, to see whether it will be stored or it will be infiltrated, or some portion of the water will act like a runoff. That is nothing but the surface runoff. Right? Now here two different sorts of experiment is being done. This is basically infiltration model, right? How infiltration actually working, right? So two intensities are there. I have already told you in the last case. Low intensity rainfall, high intensity rainfall. We are having this one which is having pores, so basically this is nothing but the infiltration. In this side it is also infiltration, right? Okay, now we are having another pot, and which is having a certain depth, which is having a pipe which is having a certain depth. That means after reaching this level only, then only the excess water will be going through the pipe in the next section. And what is this? This is basically the soil moisture content. I have already told you that soil will hold some amount of water with respect to its capacity. Now this is the capacity of the soil. It will hold this amount of water, then only the excess amount of water will be again flow downwards and will meet the groundwater level. This is the groundwater level. Here also. But what is the difference? Here in this direction we are having low intensity, here we are having high intensity. If low intensity is there, all the amount, if it is lesser, I will come back to that as well, that if this intensity is lesser than the rate of infiltration, obviously infiltration rate will be there. That means the amount of water which will be infiltrated in a particular time, that will be infiltration rate. Now if the intensity is lesser than the infiltration rate, obviously all the water will be infiltrated. If it is not, if it is greater than the infiltration rate, the excess amount of water will act like a runoff. Then what? It is actually storing the moisture content right now. It is increasing the moisture content right now.
স্যার মেডিকেলে যাবো
যাও, হ্যাঁ অ্যাটেন্ডেন্সটা ওদের দুজনের বলে দিও তো। তুমি আসো, ঠিক আছে। So after that infiltration, in this case, the amount of water is being stored as a moisture content. Here, it is already, as because the infiltration is in a high rate, the maximum rate, as because the runoff is occurring, that means the infiltration is rate is at the max. So what will happen? A large amount of water will be infiltrated. Eventually, this moisture content is fulfilled, saturated, excess amount of water will be going to the groundwater table. This is one model that how the infiltration is happening, what is the procedure, right? Here you can see, as because it is not saturated, no contribution is there to the groundwater table. Okay. Now again, definitions will be there. First definition is infiltration rate. Infiltration rate, I have already told you that term, right? Infiltration rate, that is the volume of water soaked or infiltrated per unit time. That is infiltration rate. The existing rate at which water flows through a given soil at a given time is termed as infiltration rate if the unit will be centimeter per hour, millimeter per hour, or something else. Here as well, we are considering the depth, not the total volume, as because if your area is known, you can find out what is the total volume of water. So we are considering again the depth of the water soaked by the soil. Yes. Now what is this? Infiltration rate is nothing but the existing rate which is actually happening in your field right now. Here, now the rate will be dependent on many things, and the the maximum rate can be different, and we are having a different value for that. Now here it is, that is called the infiltration capacity. A capacity, whenever you are telling or saying, capacity means the maximum it can bear or maximum it can do. Capacity, that is capacity, right? So the maximum rate at which a given soil at a given time can absorb water is defined as the infiltration capacity, FC, and unit will be same. Now can you find out the difference between the infiltration rate and infiltration capacity? Infiltration rate is the bastov, right, is the fact which is happening right now in your field. Maximum rate by which it can soak, that will be the infiltration capacity. If infiltration rate which is happening, if it can be max to max equals to infiltration capacity, it cannot be greater than infiltration capacity, like the last one, PET and AET. So F can be equals to or lesser than FC. Here it a fixed value কোন একটা particular soil এর জন্য, by the way. While various factors can be there, right? So if you are having sandy soil, infiltration rate will be higher than the clay soil. So what can be the relation between F and FC? What can be the relation between them? Is not only F and FC, but F, FC and I. Now what is I? What is I? Intensity of rainfall, right? লসেস পড়তে পড়তে রেইনফল ভুলে গেলে নাকি প্রেসিপিটেশন ভুলে গেলে চলবে না। This is from the rainfall in, right? I've already told you in the model, right? If infiltration rate is higher than infiltration capacity, that rainfall intensity or lesser than rainfall intensity or not. So I is basically nothing but the rainfall intensity, and that is also in centimeter per hour or millimeter per hour or something else. Now F will be equals to I when I is lesser than FC. What does it mean? What does it mean? Go back to this model. It is having some capacity, maximum rate by which that water can be infiltrated inside. If the intensity is less, the rainfall intensity is less than the capacity, all the water will be infiltrated. And if then what is the infiltration rate right now in the left hand side case? Infiltration rate is total rainfall which is occurring is being infiltrated, that is the infiltration, total amount of infiltration. So basically the infiltration rate right now is equal to jotota jol asche, that is the amount of the intensity of rainfall, as because it is having a larger capacity. Yes, if it is not, then obviously if it is not, F will be equals to FC. In the second case where the intensity is much higher than the capacity, runoff is occurring, এতটাই high যে runoff is occurring, that means what? All the water is being infiltrated in the soil by its maximum capacity, it cannot take anymore. So that is why the runoff is occurring. Clear? So that means right now in the field the rate of infiltration is equal to the maximum one, that is FC. So F will be equals to FC when I will be greater than FC. I will be greater than FC, and the remaining portion will act like a surface runoff. Yes. What are the factors there can be? I told you that there may be several factors by which the rate of infiltration will be dependent, right? By the name itself, eventually we can see that infiltration capacity of the soil is affected by number of factors, that is soil characteristics. I have already told you, if it is sandy soil, if it is not sandy soil, if it is clay soil, obviously in sandy soil the rate will be higher, in sandy soil, in clay soil will not be the higher. Compaction, right? Compaction of the soil, if it is well compacted, right, then obviously the pores will be lesser. That means rate will be lesser. Surface covered, if it is covered surface or not, right? Soil moisture is one of the factor as well, as because if it is dry, it will soak in a higher rate. If it is fully wet, obviously there will be some sort of runoff. Yeah. Temperature is there, water quality is also there. So those are the factors by which the infiltration capacity will be affected or may be affected. How we can measure the infiltration? To measure the infiltration, those are the instruments out of which those two type of instruments are largely used, that is called simple tube type infiltrometer, evaporimeter, infiltrometer, double ring infiltrometer. So in simple tube type infiltrometer, you can say one ring is there or one tube is there. In double ring, two rings will be there, nothing else. এখানে দেখানোর মতো কিছু নেই, আপাতত দেখাচ্ছি না। Two rings means one ring and inside one ring another ring will be there. So one tube, if you consider, obviously the depth will be lesser in this case, so the depth will be like this, right? So one tube will be there, inside one tube, another tube will be there. Now what the this experiments are simple. What you have to do, you have to insert the ring inside the soil surface in which you are trying to find out what is the infiltration rate. You have to insert the tube inside the soil surface. Then what will happen? You will pour water. You will pour water. You will see what is the time right now. After a certain time, you will see what is the change in the depth. Or if you are maintaining the level, you can see what is the amount of water you are adding in that particular time. So you know what? You know the volume of water which is actually going inside in a particular time period. Divide that, that will be the infiltration rate. Simple, right? So if it is so simple, why we are going for this one? We are going for this one for this, right? You can see this flow of water. Why? जब बारिश होगा, बारिश एक जगह पे नहीं होगा. It will be totally on the field, right? It will not be occurring inside. In this side there will be no barish. It will not like that, right? So what happens, that as because you are pouring water and the water is being infiltrated, it will not flow vertically. It will flow in this direction as well. As because you are not providing water in this field, so it will be spreaded like this one. So because of the absence of the water in the outskirts, the volume of the water soaked by the soil will be higher, as because it is spreading in the sidewise as well. So you are getting a wrong value, that is a higher rate you are getting. As because जब बारिश होगा सब जगह में होगा, so it will follow vertical. So to avoid that, what we can do this, that is two ring, one chamber, one cylinder, then inside another cylinder. Then what will happen? We will pour water in both the rings. So outer ring and in inner ring, right? We will pour water in both the rings. So from the outer rings, it will go outside. It will, obviously you are not pouring in this side, so it will flow in this direction as well. बहने दे, उसे बहने दे, right? But as because we are having water in this direction, this chamber, from this chamber water will flow vertically. Now do not consider these two, consider this one. What is the change in water volume per unit time? That is a almost accurate infiltration rate of your field. You are having this double ring infiltrometer in your lab. This is actually kept in fluid lab, right? যখন হয় ওটা ফিল্ডে নিয়ে যাওয়া হয়, you can see it, right? You can, obviously with the specific dimension. I'm not going into the dimension, but obviously you have to remember. If short notes are there, you have to remember those dimensions. Curves of infiltration capacity and cumulative infiltration capacity with respect to time. ছবিটা দেখবে, দেখে describe করবে, try to understand what the graph is telling to us. From this graph, what you are getting, what are the ideas you are getting, right? Now Horton's equation is there, by which we can find out the FP, that is infiltration capacity, right? Infiltration capacity, where F0 is the initial infiltration capacity at 0 time, Fc is the final steady state जब infiltration rate is eventually, if your soil is dry, the infiltration rate will be higher in when you are starting the experiment, right? As because যেটা বললাম, the water will be absorbed by the soil faster, as because it is dry. After the saturation, the infiltration rate will be not maximum, infiltration rate will be fixed, right? It will not vary. A lesser amount of infiltration will be there, a steady infiltration rate you will get. So initially the infiltration rate, this graph is showing nothing but this one. This graph is showing that thing, that with respect to the time, what will be the infiltration capacity. So initially infiltration capacity will be higher, gradually it will decrease, after a certain time it will be a steady infiltration.